All right. Um, Thanks for coming. I promise you, this is probably one of the weirder talks you'll hear around here because we normally hear about computer science, more geeky stuff, and this is really weird and wild. So I owe you, of course, an explanation why, as a computer science, I give a talk on Titanic, and you'll see in a moment how that all connects. So my talk will have like three parts to it. One is, what do I really do in my scientific work, and how did I actually get into this to participate in a Titanic expedition? And then talk a good piece about the experience of actually doing it, and then the disaster we all heard about last summer. I'm probably among the last 5 human beings who will have seen the Titanic with my own eyes, because after this disaster, I'm sure it will be years before anyone will actually go down with a submarine again to the Titanic, because it's probably going to get regulated or tested and checked and whatnot. So it's unlikely that it will happen soon. And by that time, the Titanic will have disintegrated and fallen into the mud at the bottom of the ocean. It's already falling apart. There are rusticles, as you will see in a moment, that grow on this legendary wreck that gradually eat it up. And so it will eventually collapse in itself. And people predict that should happen in the next few years. So let me, with all that as a preface, let me begin by telling you why I got into this, and what my research actually does, and why I would end up in a Titanic mission and then be on the same submarine that would then later collapse only just 2 missions later, and give you a bit more of my observations and insights from this experience. So what do I do in my day job? Most of you know, as in my scientific work, I work on this problem of language, removing the language barriers, and spent all my career doing it since 1979, when I started with this dream of building machines that would translate from one language into another. And in 78, 79, I was at MIT working on a speech synthesis system, was the first speech synthesis system at the time. And I came here to Carnegie Mellon because we needed the speech recognition and the translation components to really build translation devices that would go back and forth to translate between people. Why is it a problem? 7,000 languages in the world. How do we communicate with everyone? It was a question. It's not possible to do it by human effort. And so we must have machines that help us out if we want to ever get understanding between the people of the world. So we began early on in the 90s already, when I came here to CMU, to put together actually a first system where we would have a speech recognition, machine translation, and text-to-speech synthesis as a machine where you can speak into it, and on the other side would come out as spoken language in another language. In 1990, this was unheard of. It was crazy. When we started, this dream was totally impossible, and people didn't think it was possible until later in 2009, and I can say more about that later. So if you want to have a dialogue system, of course, you have to do this all in reverse, be able to talk in the other language and transmit it back into your own language. Now, our first system was then in 1991, where we had a first, brittle little system where we could, with a vocabulary of 500 words and a restricted syntax, we could actually demonstrate this to the world, that it would be possible to have a dialogue systems between people. You younger people here cannot imagine what that world was like, because you travel around and everybody pulls out their iPhone and they talk with each other. These were days where there was no iPhone, there was no internet, there was no Google, there was no Apple, there was none of this. I wrote letters to my mother and put them in a mailbox, and 2 weeks later she would get I would get a response, maybe. So in those days, it was nuts to try to do something, and we were pioneers in 1991 to demonstrate this very first system that could actually allow us to do a first video conference between 3 places to do that. It took another 20 years until 2009, and 10 companies along the way. I started many companies, and the 10th 10th company was a company called Jibigo, which produced the first speech translator on a phone, where the entire speech translator was on the phone, and we sold it through the Apple iTunes, which just had come around. So everything just came together. We had strong enough hardware. We had a app store by which we could market. We had a startup company, and we had the technology to do it. And it was at the time a sensation. We sold this on the App Store, and it could do pretty much any dialogue you would want to do in travel or medical, and it sold extremely well. The company was then later, the reason why you don't recognize the name Jibigo is because the company was then bought by Facebook a couple of years later, and you see us onboarding here. Facebook, to my regret, my chagrin, never really used it as a speech translation dialogue machine, but used the components and built up speech technology at Facebook and also the language translation for posts. We continued, though, to do this in humanitarian deployments. We still do that now with the migrant crisis in Germany or Europe, where medical patients come into hospitals, and for them to communicate with doctors, we built these devices that provide speech translation between multiple languages, and we still do this to this day. We then also progressed to another version of speech translation, which is these lecture translation systems, where you can do a monologue like I'm giving right now and have it continuously translated. Vocabulary is larger. You have to keep up with the speed. You don't know where the sentences begin, where they end. So the machine has to do this all automatically. So it was a bigger challenge for us to do. But that too, we had eventually achieved in 2005 in a press conference we had here at CMU and also in Karlsruhe, my sister lab over there. And in 2012, we introduced this as a product or as a deployed system in all lecture halls, or in 5 lecture halls at the Karlsruhe University, as it was called at the time. And students would come and go to their website and then get automatic translation and transcription of the lecture as it's going on, so that a foreign student could go to a German university and listen to a German lecture and actually understand what the lecturer is talking about. We then got invited to do this in the European Parliament. We had first deployments in the European Parliament in 2013, 2014, where we actually installed these in the Parliament and gingerly worked with the interpreting directorate. There are, Parliament spends like hundreds and millions of euros on translation and interpretation services, and they have some of the best human interpreters in the Parliament doing the 23 languages. And we came gingerly with our system to see whether we could actually match that. But we actually developed a good friendship with them because they saw that the technology wasn't perfect. And we saw opportunities to introduce this technology in areas or at times when Parliament didn't have these interpreters at hand. That ended up in another startup company, Kites, that we formed in Germany, which then subsequently was acquired by Zoom. So if you go on Zoom and you connect to your friend somewhere else and you go to the closed captioning button underneath your Zoom call, and if you have the proper license, of course, you can also select translation languages. So you can on Zoom right now get my lecture translated into Chinese if you want, or Japanese, or one of 30 different languages. It's there. It's available. It's today and a technology that we can use. And we're, of course, very proud. It took only 40 years to do this, but we eventually succeeded in doing this and bringing this to the world, and quite happy with it. So here's our team in Germany, the Zoom team. They have a whole research lab there developing this technology and moving forward. I don't want to bore you with this detail because this is talk about the Titanic, but we have a number of milestones that got us to there. And as we now look forward into the future, we ask ourselves the question, by having achieved this to be on Zoom, a complete subtitling in multiple languages, are we done? Should I retire? Or the R word? So we say, no, better not. Let's keep going, because we still can't completely do it. When you watch movies, sometimes movies get dubbed, right? Not only subtitles. I don't know about you, but sometimes when it's a Friday evening and I'm tired, I don't want to read subtitles in a movie. And then it's nice to have it dubbed, so that you can listen to the dialogue. Except the problem is that these dubbing means that there is a human actor who speaks the translation just so that it matches to the video. But very often you know that the translations don't come out right. The lips don't move in sync with what the speaker says. And the translation is sometimes odd. And the voice is no longer like the original speaker. So you listen to Arnold Schwarzenegger dubbed into German, it just doesn't sound right. It has to be the proper original voice, or Japanese samurai movie. If you don't have it with the proper voice, it doesn't really give the same impression. So we are developing this system with deep fakes now, with effectively ways of modifying a human face such that the lips move in synchronization with the translation. We can convert the voice from the original speaker into the translation on the other end. So we can create the real illusion that each one of us can speak 30 languages with our own voices and make that appear pretty natural. The components from that is speech recognition, machine translation, speech synthesis, voice conversion into our own voice, and then doing the neural lip sync video generation so that we can generate the video to appear in the translation. This is actually an idea where we had a student here at CMU years ago who did the first system of that in 1999. But it was so dorky and so creepy that everyone who watched it said, this is creepy. I don't want to watch a movie like this. So it was not right there. And so it took, again, another 20 years for us to have the technology that can actually do that. And I'll play you a little video of where we are now.
Wir fangen heute ja mit dem tatsächlichen Stoff an. Bitte zunächst mal
I'm giving to German students in Germany. So if you're not a German student, you may find this difficult to listen to, so you'd like to have it dubbed into English.
Super, then I warmly welcome you again to our lecture on cognitive systems. We are starting today with the actual substance. I would like to apologize for the delay of a few minutes. We still fought with the technique here.
And if you say, Alex, this maybe is tweaked because Alex knows how to speak English, so this is a fake, but we can do that in Japanese, which I do not speak properly. And if you believe this is all doctored because it's my face, we can.
121. The Smart City Institute.
We can do that with our president.
Has become a campus-wide initiative that encompasses so much of our work at the intersection of.
So Farnham does not speak German, he does not speak Japanese.
スマート知的研究所はキャンパス、ホワイト、イニシアチブとなりテクノロジーと社会の交差点における我々の仕事の多くを網羅しています。テクノロジーの政策と実施焦点。
Or German.
このコース、21, ein Smart City Institute, das zu einer Campus-wide Initiative geworden ist, die so viel unsere Arbeit an der Schnittstelle von Technologie und Gesellschaft heute umfasst, ist eine feierliche Arbeit von.
All right, now I hope I convinced you that we can do this reasonably natural so that we can actually have even our president talk in English, German, Japanese, and any one of 30 languages we choose, and create a convincing video. Now, what does that have to do with Titanic? This is, of course, something we do for language translation. But privately, personally, I live in Seattle, and I just by coincidence came across some news and websites that said that there is actually a company that does deep dives. I'm also a scuba diver, and I like adventures and fly helicopters and things like that. So I was intrigued by this company that does deep dives in submersibles in different parts of the ocean. And as so happens, they were in Everett, which is very close from Seattle. So I decided to drive up and take a look and meet with the people there. So I met Stockton Rush, the CEO of the company, and the submersible that they were developing and that they had developed, and they will be talking to you about today. I found out that they were doing dives in various parts of the world, including the legendary wreck of the Titanic. So I decided to look closer, and that they were actually having missions coming up in 2022. Now, one problem that I didn't know about in submarine operations is that communication is actually really difficult because you cannot radio communicate underwater. I wasn't aware of that, but if you think about it, it may sound natural. You don't have GPS, you don't have Wi-Fi down there. So how do you communicate with a submarine? The only major way to do this is sonar. And sonar is an acoustic signal that has very low bandwidth. There are attempts to do phones, etc., but I don't think they work very well. So communication by voice is actually very hard to do. So how does OceanGate do that? They have a sonar system that goes between the submarine and the surface, and they text message because that's much lower bandwidth. So they text messages to the surface to tell them how deep they are, where they are, and then they get instruction from the ship because the ship knows where they are, where the ship is, and then they can text back the position of the submarine down to the submarine. Now, all of this is very slow, and you can't really talk, and you certainly can't do a video conference. So I have this conversation with Stockton Rush, says, well, we're developing stuff like that, where we can actually convert voice on one side into text, and then technically we could convert text back into transmit text, and then resynthesize the text as voice with or without the language translation. That's immaterial here, and then generate synthetic voice with your voice at the surface, and then generate a video of yourself on the other end. So to say this again, what we can do is we can recognize speech in the submarine. We can transmit it via sonar to the surface. At the surface, we can produce synthesis, and then by voice conversion, generate a video of the speaker in the sub up at the surface. So we developed this, and it looks like something like that.
Hello, I am Stockton Rush, CEO of OceanGate. On our research mission, we are planning a deep dive to the legendary wreck of the Titanic.
I am Alex Waibel. We are excited to be part of this mission. Our role is to contribute to better communication between the submarine and the ship on the surface. Such communication is crucial. Unfortunately, normal radio transmission does not work deep under the sea. That is why we are planning to try a different approach. We are recognizing speech in the sub, and we transmit text via sonar signals to the surface. Finally, we resynthesize lip synchronous rendering off the video and speech off the speaker.
So we developed that, and in the meantime, of course, studied what Titanic was all about and how we actually could participate in a deep dive to do that at the wreck of the Titanic. Now, Titanic, this is the second part. You all heard about this legendary wreck. It sank in 2012. There are many movies made about it because it's very well documented what happened. There are some very interesting human stories about it, and it still has a lot of fascination to people. There are entire clubs, societies devoted to Titanic who publish every detail of the Titanic, and it continues to be something that people are quite interested in learning about. It sank in 2012, was the greatest maritime disaster in history. There are 2,224 passengers who were on board, 1,514 were lost, only 710 were saved, and it's still one of the deadliest peacetime sinkings. It broke apart as it sank. The bow went down like a torpedo, and the stern went straight down and disintegrating as it went down. There's a very good computer animation that is done by James Cameron, the movie maker who made Avatar and many other movies, which shows this quite nicely.
Oh, absolutely. Yeah.
Let's put this to bed.
There we go.
All
All right, that was good. Ships veering to port from 22 knots. Sideswipes the iceberg. Murdoch ports around the iceberg, try to keep from hitting the propellers. That was pretty good. Okay, so now we're watching an accelerated time. We see the first 5 compartments flood. They equalize pretty quickly. Bows pulled down. We see the port list. Port list looks right. Now it's about 9 degrees. Well, you can really see the effect of that list on the flight. So yeah, superstructure starts to get pulled under. Funnels collapse at their base. Now the bow is accelerating downward. That was good. We're starting to see the stern come up. We got our maximum peak stress, and yeah, boom, brakes. Okay, bow swinging down. That was good. The double keel hang on. Then they separate. Bow plunges straight down. Right, got mast snapping back. The funnels are rooting backward, pulling off all the data. Bow's going down like a torpedo. Here's the angle when it falls through into a stable position. Let's see the stern. Heeling way over to port, that was right. And she goes, yeah, that's right. She goes almost vertical just when she goes under, and then boom, forward. Now she accelerates, and all the stuff starts to rip off. See the shell plating going, there goes the double bottom frisbeeing off. And the stern's falling through. So now the stern's falling aft and down. And we see the spiral. The bow is pulling in a stable position, and it hits, yeah, boom, it kind of breaks its back. And we see the hydraulic go first with the downwatch effect. Let's see the stern. We see the shell plating blowing off, decks, everything kind of settling around it. Like a big airplane crash site. Bada bing, bada boom. That's exactly what we're looking for.
So as the video shows quite nicely, it broke apart and went down in 2 different pieces. The front is fairly well maintained still. It's went down as a torpedo, like it showed in the video, and the back really disintegrated quite badly. So at the stern, at the back, you find a debris field of lots of different metal pieces strewn all over the ground, while the front is still nicely visible. So the Titanic was discovered then in 1985. There were actually 2 missions. They have an interesting historic background there too. People searched for it and couldn't find it. And eventually they found it at a quite deep depth, at 4,000 meter depth. And it was almost coincidental because the first mission just barely missed it by a few meters as they were scanning the ocean floor with sonar and image devices. And so in the second mission, then they actually found it. And the way they found it was by taking pictures of this. And this is quite a remarkable picture because it shows these 3 round circles, right? What they are is this entire thing is a boiler of the Titanic. The Titanic had several of these boilers where people put coal in it, and then they fired the boilers to drive the engines of the Titanic. These boilers were gigantic. They're probably bigger than this room, and the doors are big doors also where they shoveled the coal inside. Now, why is it? Because they have such a distinctive shape, they knew immediately that they had found the Titanic when they took pictures of this, when they took this picture, because it was so descriptive and so typical for Titanic design. Here's a picture of the attempts to find it. They called it mowing the lawn. They had these sonar and visual sensors scanning the ground of the floor and going back and forth and back and forth. And these were initial missions done together by the French and by American Navy people. And eventually Robert Ballard, by coincidence, actually the weather turned bad. And so the first mission missed it by a few meters because they were drifted away. And then in the second mission, the Americans went over and actually found it because they just were a few meters further and then found the Titanic. So this is how it more or less looks like, and it's at 13,000 feet or 4,000 meters. The water pressure at 4,000 meters is roughly 400 times the surface pressure. It is completely dark. It gets dark below 300 meters. It's pitch black. You don't see anything, and there are, of course, few life forms. 400 times the pressure on the surface is enormous pressure. There's only very few submarines in the world. Most military submarines don't go that deep. And there are just some special research vessels that are designed to sustain these incredible pressures to go down so deep, 400 times the pressure on the surface. So back to what we were then doing. We were then developing our system to try out this communication device. Even though we had all the components together, it still required quite a bit of additional work. We had to have an appropriate web design to make this work. We had to reduce the speed of making the entire resynthesis work. We also had some sort of sectioning that we worked on, because when you're in the submarine, people don't just talk messages to the surface, they talk with each other. Sometimes there's chit chat, sometimes they're reporting or documenting what they're seeing. And very often, as I could show you later, I have videos of recordings of our own dive. When you're really at the bottom, it's so stressful that the whole speech becomes very fragmentary. And, you know, people are also worried and scared, as we will see in the moment, to not run into objects down there. So the voice and the speech becomes very fragmentary and stressed, and that obviously poses challenging problems to these language processing algorithms. We had also programmed to text stuff to the sonar, and we had an offline submarine onboard performance that we measured. We didn't have any internet, so again, we had issues with doing everything on the laptop. And so since we're now doing all these deep neural network, you'd have to basically have a GPU on the laptop. And at the time, there were only a few machines or laptops available, because you can't put a big server on this small submarine. So we had to all squeeze it into a small laptop. And we did with a laptop. Unfortunately, it had only a battery life of about 2.5 hours. And the dive takes 9 hours. So now we had the possibility, do we take extra battery packs along? And in the end, we elected not to do this, because some battery packs also emit gases, and you don't want to have gases in a closed submarine at 4,000 meters depth. So, and I didn't want to go into the history books by saying Alex Waibel was the one who exploded the submarine underwater. So we decided not to do it and simply go with a laptop and then select 2.5 hours during which we would do the test. Initially, we had intended to do that during the bottom time, but later it got so stressful that we decided to do it on the ascent. As soon as we were done working on the bottom, we had the recordings running all throughout, but the actual laptop performance and transmission experiments, we did then immediately after, during the ascent. There's, of course, speech issues, vocabularies, echoes, background noise, music, all of that plays into this. On the way down and on the way up, people played music. It's boring, and it's also releases the stress by having just music. So we all agreed the only music that we disallowed was country western. Everything else was cool on the submarine. And so we listened to rock and roll and whatever. And of course, between June and July, we tested. We were still wondering whether we could make it in that same year or whether we should postpone to the next year. And I'm glad we pushed ahead and did it that same year, because I wouldn't be standing here talking to you had we waited for another year. And of course, the stressful thing about doing a speech recognition experiment like that, you have only one shot at it. You can't do this ever again. And so it better work. So we did some early experiments in Everett, north of Seattle, in a smaller submarine, which we basically just sunk down to the bottom of that harbor, which was probably just 10 meters or so, and collected some data and tried some initial experiments with it. And then we were, I think, getting ready, developing the system for the actual dive. Now let me go and tell you a little bit about the technology of OceanGate and the particular submarine or submersible that we use, because that will also later on be crucial in explaining what actually happened with a disaster. Typically, when people do these super deep dive missions, they have these incredibly heavy Titan-based submarines that are made out of Titan, many thick walls like that to sustain the pressures. And of course, to put them into the water when there are waves, you're on the ocean and there's movement on the ocean. How do you put a big thing like that that's so heavy into the water without hurting anyone or without hurting the actual vessel? It's done in many previous missions. People have done it with so-called A-frames. These are these enormous structures that essentially tilt back and then put the submarine into the water. But once again, you can only do that when you don't have major waves, because it's a very delicate operation. As soon as you're outside the water, everything shakes and so forth, and then it's actually very dangerous and difficult to put it into the water. And of course, they're costly and they're huge. Now, Stockton Rush, the CEO of OceanGate, he's now pretty much very much maligned in the media as some guy who did it in his backyard, etc. It's all BS, frankly. I've watched them develop this thing and looked at this, and yes, maybe corners were cut. We'll talk about this later, but by and large, it was a lot of effort also to make this safe. But there was also a passion to be pioneering, to make deep ocean dives available to everyone, more or less, to make it so simple, easier, so that it becomes like flying an airplane. It's that kind of pioneering idea to make it accessible to everyone, just like aviation now is. And so these submarines or submersibles would have to be much lighter, and hence, the entry into the water would have to be much easier. So Stockton Rush came up with this design, which you might argue with, and we argued a lot on our missions over this, but the idea was to put it on a platform, the submarine or the submersible, and then push the entire platform into the water, and then vent the air. There were some air containers on the side, and if you let the water out, the platform sinks, and then the submersible is just in the water. Then they did a whole bunch of safety checks, and once they were all completed, it could then essentially drive off of that platform in the water, because now you're with the water and it's not shaking outside of the water. So that was the idea, and this would explain then how the rest of it then goes. So here you see the Titan on the platform swimming in the ocean behind the ship. This is what it looks like when it's in the waves. It's basically a boat on which the submarine sits, and then once it's underwater, it can be released or detached from that platform and then drives off with the thrusters. It had electric thrusters, and with these electric thrusters, the submersible then can move around at, I think, 3 miles per hour or so. So it's a good way to get around here. Here you see it on the descent. Once it's in the water, you can flood some of these air containers so that the submersible naturally sinks. And once it sinks, it can then also be driven around by the thrusters. When the submersible is then recovered, once again, you park the submersible on the platform, and then the platform is recovered by literally pulling it up on the back from over this ramp. This is what it looks like. It can go roughly 3.5 miles per hour in speed by the thrusters. It can seat 5 people inside. It has life support for 96 hours, basically 4 days, for a crew of 5 people. It's not very large, but it's like a minivan. Imagine like sitting in a minivan with 4 of your buddies, and you just do the dive like that. It's literally like a like a minivan. It does have a toilet. Lots of people ask whether, but it's really more like a potty. It's not terribly comfortable, but it had those kinds of levels of creature comfort. So here's again in Seattle, Stockton Rush, the CEO. He is one of the people who passed away this last summer in this accident as he was steering the submersible himself as it went down to on this last dive. So this is what it feels like when you sit. You sit on the floor in this submersible, and there's one viewport in the front, and there are screens in the back. There's cameras all over the outside on the submersible, and on this back of the inside on the big screen, you see what the camera is actually looking at. So you really have a 360-degree view by way of the electronic cameras, and in the front the viewport. Of course, initially everyone wants to sit at the front in the to peek out through the viewport, but then when it gets really cold at 4,000 meters depth, it's more comfortable in the back. So this is what it looks like. You sit like on the floor pretty much. Okay, so a word about the ship. These big ships where the submersible and the platform rested on, you see it here on the left, the platform and the submersible on the back of this big ship. Now, what are these big ships normally doing? These are gigantic work ships. What they do very often is save oil platforms from icebergs. So oil platforms in the North Sea, for example, they sit there and icebergs come drifting towards them. And so that icebergs don't destroy the oil platforms, they actually call in ships like these, where they put a big stake in one side and then go around with these huge steel ropes and literally lasso that entire iceberg and then pull it far enough to the side so it doesn't run into these oil platforms. So these are the sorts of things that these ships are doing. And as you can see, they have enormous winches and a big platform in the back from where you can actually work and build and do repairs on the submarine and so on, and launch it from these ramps. It's 7 stories high, so by the end of a mission, you get in pretty good shape going up and down to lunch and dinner. And this is it's all modern technology, GPS controlled and automatic cruise control on this and so on. Now, on to the actual mission, 2022. When we went, we had 2.5 hours down, 3 hours at the bottom, 2.5 hours up. So several hours for launch and recovery. So it's a full day's worth of activity. We took the ship down to the location where the Titanic wreck is. And again, by driving out, we had fun along the way. We signed some flags and raised the flags. I get to know some wonderful people. Among other things on my mission, there was Pierre-Henri Najolet. He's the second one of the people who passed away this summer. He's an explorer who did 35 dives to the Titanic. And if you go to any of these displays in Las Vegas, and I believe there's one now in Pittsburgh, many of the artifacts were recovered by the missions that PH actually ran. Amazing guy, French native and wonderful human being. Very, very nice person. I really enjoyed my conversations with him. Rory Golden, very funny, also explorer. He did several dives to Titanic before and knows the wreck quite well as well. He's from Ireland with an Irish accent. And David Concannon, also a very good friend now. We meet regularly now and have dinners together and discuss various things. He recovered for Jeff Bezos the Saturn engines, who went Apollo 11 took Apollo 11 to the moon, the first moon landing. Remember, there was such a thing. It was not a hoax. So the engines actually dropped into the ocean, and so he went down with several on a mission for Jeff Bezos to recover them. Jeff Bezos wanted the engine. Don't ask me why, but he did that. Of course, we had fun too, doing.
A romance is waiting. Oh.
Okay, not my best singing performance. Every day there were mission briefings, all about the safety again, and they had checklists, etc. So when the media kind of say, "Oh, we just cooked this up," and they took people's lives in some haphazard way, that's not true. There was a lot of attention to safety. We had a physician on board. And there was everyday briefings to see when the weather window was good enough so we could do the dive. Because with bad weather, we couldn't do the dive. And that's what actually happened during the first 3 days. We had bad weather, and we had to park ourselves north of the dive site. And so we listened to lecture, among other things. PH gave us a presentation about the wreck of the Titanic. He knows it upside down and forward and backward, every corner of it, and explained things. Rory Golden had interesting lecture on the discovery of the Titanic. And then finally the day came where the weather window was just good enough that we knew we could steam to the wreck site and do the dive. Before, while we were waiting, people, of course, are watching dolphins and whales in the mid-ocean. It's quite exciting there too. Some had the idea of going on a scuba dive, but that was rejected by the captain because there are white sharks in the neighborhood. So we just stayed on board. And then finally the dive day came, and we prepared the sub for the actual dive. This all started at 4 o'clock in the morning, so it's an all-day operation. The submarine is readied. The platform is put in position. This is us boarding. You see me here getting on board of this thing. And off we were to launch that entire platform with a submersible into the water. Then again, all the checks are done, system checks, because the radio still works. We talk with the people on the ship, and there is back and forth, just like on a space mission, where you say, "Is this system go, go, go," and then you go through the checklist. And if anything more than, I think, 2 issues are not correct, then it's aborted, and it's the submersible is pulled back on the ship. Then finally, there's a so-called stop ski where everything stops and is looked over again. And only then, when it's all confirmed, they vent these canisters or these containers so that the air goes out and the submersible sinks into, the platform sinks into the ocean. I had a drone with me, so I took this picture. Wall Street Journal actually took it as one of the pictures for this Ocean Gate missions. So we can have this actually as a picture from the air. Then finally it gets vented, and we disappear into the ocean. And this is here a picture of where that is happening. Takes a little bit to go, but you can see it disappearing into the water. So we're all in good spirits. The submersible goes down 300 meters down. It gets pitch black outside. So there's not much to do. We listen to music and argue over playlists. We raise flags from the Explorers Club or the ship line that ran the Titanic, the White Star Line. And eventually, when we reach the bottom, the mood goes from cheerful to more tense, as you can tell, because now we're actually really at the bottom and looking at what's happening outside. So this is a wide-angle picture where you see us in the submersible, and then outside We have the porthole, we can look outside and we can move forward with the thrusters. In the front, we have the 5-inch titanium outside, the only window to the outside. It's very cold. After a while, you have these condensation droplets, and so it gets kind of cold and chilly. So we have 2 kinds of clothing with ourselves so that we can be warm enough to operate down there. There is a sonar system down in the subs, but you can only see immediate things that are in front of you. So as you're moving forward, suddenly you see there's something there, but you don't know what it is. Sometimes it's just rocks, because icebergs sometimes float over this region and they melt and icebergs grab rocks from somewhere, and as they melt, they just drop these rocks underwater and they sit there at the bottom of the ocean. But it's also pieces of the wreck of the Titanic that you find particularly in the debris field. So our dive ended up at the stern of the Titanic. So we were in this big debris field, which is particularly dangerous. There was once a submarine that got stuck under the propeller of the Titanic and almost perished, but they managed to actually wiggle free and survive this whole ordeal. Now you have to be extremely careful. These are also sharp pieces, gigantic pieces of the Titanic, and again, as you're operating in this debris field on the south, as you can see there at the stern. The bow is much more intact. There's not as much debris around that, but it's also far enough from 600 meters, 2,000 feet apart. We had hoped to do it all in one dive, but as it turned out, we ran out of time, and the second dive then was done at the bow directly. In the stern, we actually found several of these, 2 of these boilers. They are now overgrown with some of these corals, as you can see, and you see the real boilers of the Titanic here from a book on the right, and they're impressive structures when you're driving around them with a submarine. You do see some life down there. There are ratfish and stars, and once in a while, and then as we are moving forward, you get to these pieces, and you say, "What is this?" And they're jarring metal pieces, so you have to go really very carefully. And if I had enough time, I could play you some of the videos from that part of the dive, where in the front, Rory Golden was saying, slow down. And it gets really tense because you make one mistake and you're gone, your history, because these pieces are quite dangerous. They're hard to see at a distance, and as you go closer to it, it's all pitch black outside, as you know. So these are all the lights from the submersible. The sonar hits, but it's hard to tell what it is and how big it is, so you have to approach it very gingerly. So we got to this piece, and so I imagine maybe this is a piece of metal there on the floor. So I sent an email after the dive to Rory Golden, who knows these pieces, and says, "Oh, how big is this thing? 2 meters, 3 meters?" And I said, "Oh no, this is a whole section of the Titanic. This piece here is in fact a whole section." You see these little round circles that he encircled for me were actually portholes from that section of the Titanic. So huge pieces, massive things, very dangerous. I had a chance later just to give you a bit of a sense for the size of these things. This is a display in Las Vegas, a wonderful display. If you're ever down in Vegas, go see it. It has a lot of these artifacts that were recovered by PH and others. And it has one big piece that was a piece from the Titanic that they recovered actually from that depth and have it on display there. Now back to my speech experiment. We were sitting there all mic'd up, as you can see, the whole conversations we recorded. And then there were some issues with the sonar. So we had 2 sonar pieces, and one of them promptly failed. So we couldn't really go through the sonar that we had intended to link up to. So we had to actually directly copy what got out of our recognizer into the sonar of the operator. But the operator was also texting to the surface. So as we were at the bottom, they didn't want us to mess with the only one sonar that was working, because this was life critical. So we said, well, okay, let's just wait until we're done with the bottom time and then do the test on the way up. and indeed on the way up, we put these messages through and could prove that this actually all worked, and we had our experiment proven. Here's one of my greatest students from Germany. He came along on this voyage, and he was on the surface making sure that the resynthesis was working properly, and we could do the test. Okay. Now here's the trajectory at the bottom that we took. You can see we were down there at the stern right here. And then we wanted to make it to the bow, but there was a much stronger current than we had anticipated. And so the submersible really drifted to the northwest of the bow. And then we made 180 degree when the surface told us we were way off. We returned to it, but we had another scientific thing to do. We had to drop some current sensors because there are current tests being done at that ocean depth for scientific purposes. And then once we had dropped that, we were out of time, and they were very strict about it, saying, you know, time is up, we have to go to the surface. And later on, we were told that we were literally 50 meters from the bow on that dive, unfortunately, but we were going up. On dive 2 during that mission, there was a second dive then the day after, piloted by another friend, another explorer. And on that one, PH Narjolet was on board, and they drove it straight to the bow and took some spectacular pictures that I have also permission to share. And you see here these super pictures from the bow as we all know it. And again, when I was texting these pictures back home, people were asking me, oh, this is where Leonardo DiCaprio stood, right? Well, no, but that is, of course, the piece up front.
But you see, when you're doing that, after the hole, where I don't want to do like that. No. Wow.
And then one of the lights failed.
Sounded like one, but yes. No, it didn't sound like anything, but it went darker on the right side. Started side.
The second light failed. Yeah,
You see the anchor, the central anchor? Yep. With the raised on the top? I'm trying to see the front. Yeah. Going back away. So that's another way. Very spooky right there. Yeah, it really is.
but it came back on.
Turn a little bit.
There's some amazing other picture, other sites there. You see this round piece there, right here. That's 2 round things. Do you see them? These round things. These are the chandeliers in the ballroom of the Titanic. They still hang there as if nothing had happened after all this time in the midst of this space. Here you see that progressive decay. This picture was taken by David Concannon, whose picture I showed you. And as you can see, I think this was done 10 years prior. Not much growth. Now it's overgrown by these rusticles, which gradually eat away on the wreck. Now we go back up. The safety divers there help secure the submersible on the platform. The platform is so it's nice to see these divers because you can't open the submersible from inside. We'll talk about this in a second. And here we're being recovered by a boat and we're getting back to the ship. And and the submersible is pushed up or pulled up again onto the ship here with these huge winches, and it was a good day. Now we then steamed back and celebrated and had a good time and toasted and drank some iceberg beer. But notice here on the right side, this is we put some styrofoam cups outside of the submersible and went down to the Titanic at 4,000 meters. And when you come back up, I have a couple of them now at my house. These styrofoam cups shrink to these little shriveled up cups because of the enormous pressure pressing all the air out of the styrofoam. And it's a reflection of these enormous pressures that are down there. And then 1 year later, we suddenly get the message, disaster struck. On June 18th, all contact with Titan was lost. There was news articles all over. I was on TV basically constantly in Germany. I was at the time teaching in Germany, so all the journalists calling up wanting to know, because I'm the only guy in Germany who had just been on Titanic, even in the same submarine. So people wanted to know what it's like and so forth. So we had the...
Das ist Professor Alexander Waibel vom Karlsruher Institut für Technologie.
Okay, so I'll spare you that. But what happened actually, the sequence of event, contact was lost on 18th of June, this past summer, and it was 1 hour and 45 minutes into the dive. So when people call me up and says, what do I think about this? Well, I knew from my experience that 1 hour, 45 minutes was that they were getting close to the bottom, but they hadn't reached the bottom. And if they now lose all contact, there's only 3 things that could have happened. One is either they had imploded, or they actually made it really quickly to the bottom and got stuck somewhere in the debris field, or they had lost all communication, had an electrical failure, but then you would expect that they would rise back up. And for that, I have to tell you, Titan actually had 3 different ways of going back up in case of system failures. One was you could thrust with electricity up, put all the thrusters and really drive it up. Now, of course, if you have an electrical failure, this wouldn't work. They could also vent some of the outside vents to put air in it and then have it help push the submersible up also. And then the last one was kind of the most simple mechanism, is they had heavy lead weights on the outside on hooks. And so if all 5 of them, we tested this during the dive, as we were going up, we actually released those. And the way you release them is by all 5 people just kind of going on the right side of the submersible, and then that whole thing rotates and the weight comes naturally off of the hook. So very simple. If everything fails, you can still release those weights and still bubble up to the surface. So when people are calling me, I knew there were 96 hours of oxygen on board. So there's 4 days, and the dive takes less than 1 day normally. But it was intentionally done for safety in case something would happen. But when I heard that they lost contact, I thought 90% they actually had imploded and they're all gone. But you don't tell that to TV. If there's a 10% chance that they might still be there, you still hold out hope and see if they can be recovered, because the possibility could have been that they dropped all the weights, they surfaced and were drifting somewhere, and because they're submersible, you're floating right under the surface, so you can't easily be seen from the surface. So that's why they had actually search and rescue missions with airplanes flying over a large area to see if they would find a submersible from the air. And then the clock was ticking, because slowly the oxygen would go away. And the most uncomfortable feeling I had was you can't open the door of the submersible from inside. It's literally bolted outside. So you're bolted into this structure, and you need an outside crew that bolts you out. I learned later from the mission director who came over to dinner at our house just a few months ago, that they could actually explode the bolts, but then, you know, you have it open, the whole thing sinks, you have to fly out, and your eardrums would be probably hurt, etc. So it would be unpleasant either. So unpleasant to imagine that, or unpleasant to have imagining people, you know, suffocating after 4 days with 4 other people and the air going, it's a horrible thought. So it actually happened then as I had initially imagined, which mercifully probably was the easiest, is that it actually had imploded, because that's instantaneous. At that pressure, when a submersible is imploding like this, it's just literally like swatting a fly. Your neurons don't have enough time to even signal what happened to your brain, so you're gone before you would even notice that something's wrong. So in a way, it's a merciful way to go. If you think about it, it's better than having a long, painful situation there. Also, as it implodes, everything gets essentially smoked, because the pressure of the air then heats up, that everything essentially gets incinerated inside also. So it's a literally instantaneous death and an instantaneous disaster, if you will. So here's the many interviews. I don't have time to play them, but I want to spend 2 more slides on a few speculations for you. One is, there was an incredible media frenzy. People said, and because he had the right ingredients, there was a time clock ticking. It was, you know, people's life at stake, and you know, it was spectacular environment, etc. So the media loved it. They just soaked this up, and there were many of the articles. Many of them that were done pretty shallow. They did a lot of injustice to all the work that was being done there on the science and also on the thinking about it and the design. And then the criticism, it's just Disneyland for the rich, because some people actually pay and support this. So I didn't like this kind of thing. What was the most common question that people asked me? What are the chances of survival, of course? And then what did it feel like? Well, like in a minivan. And would I do it again? That was the dumbest question, I thought, because of course, knowing what I know now, of course I would not, right? But would I do it again, not knowing what it is? Absolutely, yes. Life is so full of rich experiences, and science, of whether it's computer science, AI, and so forth, is exploring our universe, our environment, and that's definitely worth doing, even if it sometimes takes risks. The tragedy, what happened, implosion, as we just said, it was immediate and catastrophic under the enormous pressure. The carbon fibers are being criticized for this. You have to imagine that there were really 2 pieces to it, these titanium domes on the 2 sides, and in between there was a round cylinder made out of carbon fiber. That was an innovative design. It was intended to be more lightweight, so that it becomes cheaper to do, and then also easier to put into the water and out. And that's, of course, an untested concept. Carbon fiber is being used by wings of jet fighters and so on. And when every time you go on an airplane, you have carbon fiber, but most of the time they're for stretch, right? So if you stretch carbon fiber, it is amazingly strong. If you compress it, it can do this, right? And so to prevent it from doing this, it's laminated, but these laminates can actually go disintegrate. And so as a result, they had sensors on it to see whether there was a sound of impending crackling of these carbon fibers. And even these sensors would then give readouts like that, where during the dive, they were actually quite quiet. There was really not much fibers collapsing. But again, when the submersible is launched or recovered, they actually do have more fibers disintegrating. And so one theory is that perhaps it happened during transport, that many of these fibers actually collapsed and got broken. Here's the last slide I want to show you, because that's also intriguing. What did they actually know? Because the whole thing was a bit weird, because there was an all-out effort for 4 days, and we all had a sense that it probably was an implosion. It was gone immediately. So why was there a 4-day search? well, there was still hope. And then there were these knocking sounds. I don't know if you remember that in the news, right? And these knocking sounds were literally every half hour. And they were, you know, these are emergency signals for submariners that have had the actual correct emergency every half an hour, doom, 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 right? They had certain things like that. Nobody knows who produced these sounds. And the people that I was talking to, my friends, they're from these, they say that can't be animals, it's human-made. And who was buzzing around down there making knocking sounds? I have no idea. Leave this up to your own speculation. But what you have to imagine, the Atlantic and the Pacific is full of activity between large powers that are actually with big submarines underway, doing dogfights and interesting cat and mouse games. And that is one speculation, but it's certainly true also that the Navy probably knew that the boat was imploded the minute it actually happened, because there are sensors all over the bottom of the ocean, and nobody admits to them, of course, because nobody wants other people to know that there are sensors. But I bet you that there are sensors everywhere. Why? Your internet cables are all going through the Atlantic and through the Pacific and so forth. So of course there's a cat and mouse game to sabotage the internet cables of other people or do cyber warfare, etc. So there's quite a bit going on there. We don't know. I don't know, but the speculation is that there is quite a bit down there going on that tells us more about why it was discovered, but why the communication was also sort of weird. This is truly the last slide. You know, people say, well, is this just Disneyland for the rich? No, to me, it's exploration. You know, if you think about Columbus, you know, he went off in the day of Columbus. You know, people say Columbus, people believe that the earth was flat during Columbus. It's not true. Everyone back then already knew it was round, and it didn't take a genius to calculate how big the earth would be by just looking at the mast of ships as they sailed into the distance, right? And so Columbus somehow convinced the Queen of Spain that the earth was much smaller and that he could reach India by traveling around it, which was an obvious line. There's more flat earthers today than there were in 1500. And so people knew this, and still he convinced people to go on this crazy journey out into the ocean where you absolutely, you know, if they believed it was all water to get around to India, it would take so long that their supplies and the people, they would all be dead for sure, right? And still they did this journey, and still they convinced somebody to pay for it, right? So it's been always through in history that people took incredible risks, paid a lot of money in doing something that is totally nuts just because. And it's being done today too. Apollo astronauts, there was a crew that burned, Lilienthal and the Wright brothers, some of them died. Jeff Bezos' activities is paid by people who pay to go into space. All of these things are things that are sometimes paid by the wealthy just to promote the science and the technology. And they made severe miscalculations and errors, took crazy risks. Some perished, some got lucky. But humanity, in the end, made tremendous progress. We wouldn't be here if Columbus hadn't done this crazy mission. And so we should actually thank explorers and not just beat on them for being crazy, because I think they really are the best of our humanity to pushing the boundary. And with that thought, I finish and thank you. I know I overstretched my time, but I'm here for more questions if you have time. Questions? Yeah.
So what about the issue of, like, when you're scuba diving and you can't go up quickly?
Yeah, decompression, because when we go on scuba dive, we breathe air that's compressed air, right? So the blood saturates with more nitrogen, and that's why you have decompression sickness, because it gets released like in a soda can, right? here this doesn't happen because inside you still have the same atmospheric pressure at the surface. And that's why you have such an incredible pressure differential. Inside it's just 1 atmosphere and outside is 401, right? So that's why it's really like taking an empty Coke can and squeezing it real hard, right? And so then you don't have decompression sickness because you never breathed compressed air. Yeah, no, yes. That's no problem.
Yes. So, you mentioned there was a sonar reading about, it sounded like an implosion to the Navy people who were listening to that. And they thought, they recognized it immediately that it probably was when.
Well, now we're here in speculation. I'm not the Navy and I don't know what people are doing, right? But I know for a fact that it was reported that there was a big bang that happened that was picked up by measurements by somebody. And we just don't, at that point, you don't know 100% whether there was an imploding sub or whether there was some other noise. You just have a dark fear that could have been it, right? And so that was being communicated. But again, during those 3 days when hope was still there that they might have been surviving, people didn't want to conclude immediately it had imploded and was gone, right? And people
We were all, in suspense that whole time, but
yes.
anyway.
Well, yeah, and now I can only speculate. How certain was the information that it was imploded or not? I mean, what was communicated in the media was there was a sound, but then there's this knocking sound. So we really don't know. Does that mean they are somewhere out there, or that first sound underwater was an implosion and they're gone? And so when you have this uncertainty, you obviously want to try your best to try to recover the people that could still be alive. It could still be recoverable. So that was the situation during those 3-4 days. And then when the 4 days ran out, then all hope was lost. And that was about the time also when they actually found the wreckage pretty much down below near the Titanic. Yes.
I wonder when you were inside, did you feel like any pressure changes, or is there like anything like different to your senses?
No, as I explained to that the pressure differential is enormous. So outside is 400 times, but inside, that's why the design of this thing is so complex and why it's so dangerous, because you really have 400 time pressure difference. Inside it's 1, just the same atmosphere as atmospheric pressure we have here. And so you don't have any kind of issues with your eardrums or something like that. The pressure doesn't change because inside it's the same. It's just outside it increases. That's why you couldn't go outside and go on a dive or something. That's totally impossible at that depth, right? So no, inside really not much change other than the stress, that's dangerous, and you're moving around these metal pieces and you're 4,000 meters under the sea, right? Yes. Oh.
When you were, say, going down or up, do you feel the movement, like say when the airplane's taking off or landing, like the inertia?
No, because it just sinks, right? And when you go up, it just floats back up. So we're really not aware of the speed at which it's going up and down. You can actually, with a flashlight, that's quite nice. When you put a flashlight outside, there are these what do you call it? It's basically their luminescence, bioluminescence. You show your lights outside, close your eyes and they open up, and then the bioluminescence reflects those lights, and suddenly you know that even during the ride down, there's all these critters around. They look at this thing that's coming down and see whether it's edible or not, and then they decide it's not edible and they disappear again. So it's really not that the ocean is empty, it's really full of critters. And no, we didn't find any big octopuses that wanted to eat us. These were just sort of tiny little things, yes.
You mentioned that they could have actually blasted off the boats.
Sorry?
You mentioned that they could have actually blasted off the boats that were on the outside. So I wonder, is it possible for the human body to take that much pressure if they were able to remove those bolts somehow?
Yeah, I don't know exactly how that mechanism worked, that they could float it somehow. But that was one of the mechanisms that they said was actually possible. And as I said, the third one, the simplest one, is just dropping the weights. And that they always did. I mean, they always dropped some weights to make sure you get a natural buoyancy. And that's, by the way, also an advantage of this, which they believed was the advantage of this carbon fiber design, because it's not so heavy, right? So you can do stuff like that and in some sense make it safer, right? Had it been not for the fact that it wasn't maintaining the pressures as we know now.
From Washington, wherever, Everett, Washington, over to the Atlantic.
Yeah, they did that every year. They put that on trucks and shipped it to the Atlantic. They would test it in the Bahamas and then get it up to St. John's and so on. And again, all this motion is probably a dangerous aspect of this, right? And in fact,
you're on a truck, you're shipping the thing all the way across the country.
yeah, if somebody drops it, then that's bad news, yeah. Yes, because in the winter they had it in Seattle.
Yeah, I'm just curious, since this experience, have you done any more progress in terms of your research, doing experiments underwater? What's been the progress of that?
Yeah, no, we stopped that. We were still continuing the multilingual translation stuff. That's going very strong in our research, but we had hope that we could maybe do another dive or another thing to test this out and try it in an actual operational environment, but that is gone. I mean, we can now do it in a swimming pool, but it's not as exciting. And you don't really have that naturalness of a stressed dialogues and so on if you don't do it in the real thing. But yeah.
How good was if like your system was also good at, like, say, filtering the person's speech from, like, say, the words of a song that they're playing in the music?
Yeah, no, that's exactly one of the remaining problems. It's a big problem because you now have many noises. And then also the other thing we discovered is when people are speaking very stressful, they don't say, oh, geez, there is a metal piece ahead of ourselves. They say, oh, go, oh, stop. You know, I could play you those videos I have from I had a GoPro 360 camera, and so you can fly around the sub from inside and listen to the dialogues. They're tense, right, at that moment. And to assemble them and make them readable on the other end or resynthesizing is actually still an open question. Also, we discovered something really interesting is that for the video resynthesis, creating emotion is one of the hardest, and then also resynthesizing silence, believe it or not, because if you have that video and suddenly somebody's talking and then they don't say anything and they stop like that, it's not natural, right? So you have to get genuine silence, which is not easy. Yeah.
Collaboration with Stockton and Rush on testing your face dabbing technology by using the text messaging. Whose idea was it? Was it just kind of the two of you enthusiasts came together, like, let's try this?
Yeah.
Was there any funding involved? Like, how did that work?
Yeah, they pretty much, we got together and said, well, you know, this is actually a bad situation because you can only get these very short messages to the surface, and so communication is very poor. And then, you know, I was thinking about the technology we have. And then we said, well, what about we did it this way? And then we somehow developed this idea from this discussion, yeah.
Let's try it and see what happens. Okay.
And we do lots of things like this. You know, we now have for example, a lady with a speech impairment in our lab who you cannot understand, but we can train recognizers that will recognize her voice, convert it into text, and then we can convert it into her voice, basically. Yeah, it's quite exciting. Yeah.
I'm also curious, what was Stockton Rush like to work with?
Well, I should say all these people have huge egos. You don't become an explorer without a huge ego, right? Because you have to get huge funds. You have to explain, like Columbus, that the Earth is only half the size than it obviously is. And so you have to be stretch the truth a little and push it and so forth, right? He had that too, but all the people that I know in that kind of business, they're sort of like academics on steroids, because academics have egos, but these guys are just another class. And so he had a good piece of that too, but he was then very much, there was criticized by James Cameron, for example. But James Cameron has an ego. He has his own company and so his own interests, etc. So these guys are also kind of fighting with each other. So I found him very interesting, Stockton Rush. He had was very lively and so I liked the guy. I mean, he had an interest for science, interesting for exploration, and I like people who take risks because they really they're so full of life that they want to do this. So I naturally, I think he didn't have enough appreciation for the scientific side of things. He was more like his submarines. That was his world, right? But other than that, it's just a shame, to lose these people. And PH, for example, Najole was a terrific human being. As a person, he probably was the one with the least ego I could imagine, and a wonderful explorer. So it's a shame to lose people like that. Yes.
Safe to hypothesize that the submarine. Sorry, can you speak up? Is it safe to hypothesize that the vessel would have imploded because it suddenly lost contact? Like in all the other cases, it would have been more gradual. Is it the case that they could communicate what they were going through had it not imploded?
Yes. So had it not imploded and they would have noticed that there was a problem, they could have communicated, and then we would know, but it just completely stopped, right? So that either meant you lost electricity or communication, the sonar failed or something failed, or they had imploded and they were gone, right? So to me, those were the two hypotheses during that time. And I must say, I actually feared more that it was an implosion. And that was then confirmed by early reports of some underwater bang. But again, people were holding out hope that there might still be hope, and then these strange knocking sounds that we don't know where they came from, right? So it's still a mystery. And then also the details of the failure of the submersible are still out because the total number of dives were not that large. If you think fighter jets get much longer stressed on the carbon fiber, they don't have as much compression stress, but even the compression stress shouldn't fail after just 2 days. So people speculate there again, was it the transportation, or this summer also they couldn't get that large ship as on my mission, so they had a smaller ship, and so they couldn't pull it up on the backside, but had to drag it through the ocean, and that could have also been bad for the hull, right? But again, it's all speculation at this point. They are doing a study on it. And again, tragedies lead to more learning. That's what I'm saying. The Apollo missions and all these missions where something went wrong wind up actually leading to a great deal of study, which then advances the science. So as tragic as it sounds that it has to be loss of human life, I think that also advances humanity, in my opinion. Did we exhaust everyone? All right. Thanks so much. Thanks for coming.